So the proportion of students who buy hard copies of textbooks is claimed to be not equal to 0.3. So the population proportion is the proportion of students who buy hard copies of textbooks. The null and the alternative will form the definition. The claim here is P is not equal to 0.32. Mind you, the equal sign must always go in the null. So if this is not equal to 0.32, that is equal to 0.32. So P naught is 0.32. Alpha in this case is 0.25. Do we have n?
12 students.
N is 12. What is x? 5, the number of successes, the number of students who buy hard copies of textbooks. We can find p hat. P hat is simply x over n, 5 over 12, and what do we get?
0.416 repeating.
6 repeating. 0.4166 says that there's a proportion. We'll keep 4 decimal places. So it's 0.4166. Obviously, 0.4166 is not equal to 0.32. So one may say the claim is true. We found evidence toward the claim, but we can't jump to conclusion. Even though it is not equal to, we want to determine if it is statistically significant or not.
0.416. We use the repeating all around top.
Not necessarily. And it's obvious, if you want, you can write it as 0.4167. So, what is our null distribution? The test statistic, B, is the number of successes. For an exact test, the null distribution is we're going to do it piece by piece, binomial.
12.30. So
12,0.32 and P naught. So that is the null distribution. The null distribution is going to help us come up with critical values. How did we find the critical values for an exact test last time and the time before? What did we use? Jimmy, what did we use?
it's the binomial PDF.
It's the binomial PDF. We use the calculator. What should we use? I'm going to clear the list. And 1. Oops. Second 2. Enter. Start. First, we want to know the minimum and the maximum value for the number of successes, which is the number of students who buy hard copies of the textbook. What is the minimum value for that X? 0. And what is the maximum?
5.
5.
sorry, what was the question?
The maximum number of successes. 12, right? We have 12 students. So all 12 can, or might report hard copies of textbooks, or none of them. So the maximum value would be 12. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Good. Now over to L2. So 0, 1, 2, 3, 4, 5, 6, all the way up to 12. Over to L2 equals second with got to go to Binomial PDF. And the syntax is N, P, X. So N in this case is 12. P is the null value for the proportion, 0.32. X is all the values in list 1. So second, 1. Close paren, enter. What just happened?
It's supposed to be on this too, instead of this too, like on the very top.
Yeah. So it has to be on the very top. Second class. Use the up arrow and make sure it goes, sort of there. Enter. N, P, and X, which is list 1. Close paren, enter. Those are all the values that I get. Good. Now, what is the key difference between a right-tailed, left-tailed, and two-tailed cat? Two-tailed would mean we're going to look at both sides. So why two sides? Because when I say not equal to 0.32, it could either be less than 0.32 or greater than 0.32. So I have a critical value on this side and a critical value on that side. But since this is an exact test, the smallest value that we can get to would be 0. So we want to keep adding so that we get 0.5. Last time we looked at only one side, either left or right. But since this is a two-tailed test, we've got to look at both sides. So for 0, I have 0.00977. So I'm going to write that down. And I'm going to move over to 12. That's 1.2 times 10 raised negative 6. Eleven, 2.9 times 10 raised negative 5. 10, 3.4 times 10 raised negative 4. 9, 0.00243. 8, 0.01164. 7, 0.03957. So the goal here is we have the right side values we have the left side values. If you look at the right side, I cannot go past 0. Yes? The reason being alpha is 0.05. If you divide 0.05 by 2, you get 0.025. So on either side, I'd like to get only 0.025. When I add them, I end up getting 0.05. Well, then x is 0 up there, I get 0.00977 less than 0.025. Great. But I cannot include 1 because it goes over 0.055. So the left critical value would be exactly 0. Right hand side, now that I've accounted for 0.00977, we just have to add these values that we have for 12, 11, 10, 9, 8, and 7. I think we'd have to go all the way up to 8, but if we hit 7, we will exceed 0.05. So let's go ahead and add those values and tell me what we get.
So we're trying to see where it's going to exceed.
So when we add the values for 12, 11, 10, 9, and 8, get 0.0144. And mind you, I have some alpha value on the left-hand side. And if you said, oh, let me go ahead and add for x is equal to 7, that exceeds 0.025, correct? So I shouldn't be including that. So I'm going to add all probabilities all the way up to 8, including 8. That gives me an alpha 2, which is 0.0144. The left-hand side bit, call it 0.00977. Yes. So the right-hand side, 0.0144, left-hand side, 0.00977. So theoretically, the alpha that we set, right-hand side, be alpha 1, left-hand side, C alpha 2. We want alpha 1 plus alpha 2 to be equal to 0.25, the given alpha. If everything was perfect, then that given alpha will be, alpha 1 and alpha 2 would be exactly half, 0.025, 0.025. But have the orders reversed, 1 and 2. So theoretically, 0.025, 0.025. But what did we achieve? We achieved an alpha 1 of 0.00977, alpha 2 of 0.0144. So that value came about by adding all the way up to 8. This one is just 0 because binomial, we can't go below 0. So the rejection region is over here and over there. Where is our test statistic? The test statistic is 5. Yes. Where does 5 fall? Let's move what?
A little more than halfway down.
So maybe right here. So should we reject the notch? No, doesn't fall in the rejection region. So do not reject. No. A word of caution there. Since the left-hand side happens to be 0 exactly, and there is nothing going below that, one may argue, well, why even bother about the left-hand side? Yes, because it's exactly 0. And in this problem, one may say, let's dedicate all of that and put it on one side so that we get 0.05 instead of 0.025. So if we took that approach, yes.
So that 0.0144, you got that from adding 12, 11, 10, 9, and 8,
Yes,
but not adding 0 or 7. Because if you add 7, that goes over.
over 0.25.
Okay.
So one might say, I'm able to share this for some reason. Oops. There. One might say, well, let's not bother about the left-hand side. We'll just look at the right-hand side. And even if that, in other words, allot all of 0.05 to one side, even if that happens to be the case, when you add all the way up to 7, you will exceed 0.05, right?
Yep.
So,
I said, yeah.
yeah, so the best place to stop would be right there. So the overall alpha that we set was 0.05 in the problem. What did we achieve? We found C sub alpha 1 to be equal to 0, and alpha 1 was exactly 0.00977. B sub alpha 2 was 8, and alpha 2 is 0.0144. So the total alpha will be the sum of the two. What is the sum of the two? One, four, two, 0.0241. Does that make sense? So should we reject the null? No, we should not reject the null. Next we will find the p-value of this two-tailed test. It's going to be very straightforward. And we will do a large sample approximation. And if time permits, we'll start with its intervals.